So today we have two problems involving probability of triangles formed inside a square region. So the first problem statement is something like that we randomly draw 5 points into a 1 by 1 square region, and linking any 3 points would give us a triangle, and we need to find the probability that there is at least one triangle with area less than equal to 1 by 4. The next one does not specifically mention a square area, but we have a line segment, and we cut that is of length 1, and we cut it into 3 pieces, and we need to find that the probability that these 3 pieces can form a right triangle with area with at least one side equal to 0.25. So let's begin solving this. Um, so suppose we have a square region of length 1 by 1, and we need to find that there is at least one triangle with area less than equal to 1 by 4. So the we just need to tell the probability that there is at least one triangle with area less than or equal to 1 by 4. So so the reason that I have coupled both of these questions together is because I think if we solve like uh, some part of the second question, we can solve the first question very easily. So we need to find that there is a triangle with area less than equal to 1 by 4, given 5 points. So to start with, this square region can also be imagined as a line segment of length 0 to 1, and we need to find a triangle inside this. So the first thing that we need to consider is, if we have a triangle of let's say length x, y, and z, x, y, and z, like each side. So we need to uh, remember that neither of the sum of two sides needs to be greater or equal to one side. And using this, we have a few conditions that we can impose to uh, say that um, if we are to have a triangle inside the square area, then this triangle uh, would uh, the largest triangle that can be made inside this area, given these constructions, um, would be made by these area. So the largest and smallest triangles possible, given these constructions, can be made inside this area. This shaded area. And um, at this point, I would recommend that you can check out, there's a video on MIT OCW that gives a better explanation to what I'm going to do. Uh, but yeah, I'll just write it anyways. So if we had x less than y, So if this part is x and this part is y, then if you have x less than y, then we will have the following restrictions or constraints. Similarly, if we have y less than x, and we'll have similar constraints. So yeah. So if this is not clear to you, you can check out the MIT video. I'll try to put it around here. I don't know how, but yeah, I'll figure it out. So yeah. So using this, we'll see that we get this constricts, like restrictions, constraints, whatever you call it, and we can only like form a triangle in this area. So yeah, and if you like calculate the probability of a triangle, so the biggest triangle that can be formed would be um, so this would be root 2. Then this length would be half. This would be half. So like it won't be half, it will always be less than half, or it can be half, I'm not sure. Because like if it was half, then it would be like touching the square. So the biggest triangle that can be made is of area 1/4, and so a smallest triangle can be anything inside this. And so using that logic, probability that triangle can be made is equal to is equal to like 1/8 of the area plus 1/8 of like the lower hemisphere, the area that is 1/4. So the probability that a triangle can be made a square inside the square, so would be with 3 random points inside the square would be 1/4, and I think then we can use 5c3 and we can solve it. But we see that all the triangles, so like whatever that is, I don't think that matters, because we can move on to solving the next part of the question. I mean the next the first part of the question. So so we see that the greatest size of triangle that can be made uh, inside the square would be the area would be uh, half into base to height. That's the formula, right? Half into base into height. So yeah, we see that the greatest triangle would be 1/8 centimeter square, and so we see that all the triangles that can be made will be of area less than 1/4. So probability that made equal like of area less than equal to 1 by 4 is equal to 1. Or we can also solve it one other way. And that would be, just a second. So what we can do is we can divide this area into two parts. And then if we have 5 points, we can like drop them randomly. And we can say that let 3 points on be on this half and the other 2 points be on this half. And so let's say that like even if the points were on this side, so this would be something like this. And if this was a right triangle, then it would be then it would be 1 into half and half. So yeah, this can't be more than root 1 plus root 1 plus 1 by 4, that would be 5 by 4, root 5 by 4, whatever. So I guess, yeah, I'm not familiar with this method, so just scrap it off. Yeah, sorry. Yeah, let's continue to the second part. So we have that a probability that a triangle can be made is 1 by 4, and probability triangle can be made with areas less than equal to 4 is 1. So then the second part says that we randomly cut a line segment into 3 pieces. And so yeah, let's get back to the previous sketch. Is that possible to do? Yeah. So now we see that we can form right triangles with let's say one side, at least one side less than 1 by 4 and side less than 1 by 4. So we see that let me change the color. So yeah, so this is a triangle with side less than 1 by 4, and then this would be a triangle with side less than 1 by 4, again a right triangle. Similarly for this, we have 1 by 4, 1 by 4, and something like this, something like this, right? But if we put the constraints on them, we see that the red area is very small in comparison to the black area. And we can conclude that the probability of uh, the right triangles uh, of side less than 2.5, 0.25 is near 0. So yeah, that's it, I guess. I would definitely love some feedback on my explanation. Actually, this is a problem that I'm trying to solve myself here, and I'm kind of confused. So uh, I would appreciate some feedback on my solution. What I've said is what I believe the answer to be. But if you have any alternate insights, I would definitely love to hear them. And yeah, I guess thanks for watching. Do comment and let me know what you thought about my solution. And stay tuned for more videos. Bye.